Okay, this video accompanies the 6.5 properties of special parallelograms student companion. So question A says, what questions would you ask to determine whether each figure is a parallelogram? Well, in our past work with parallelograms, we talked about both pairs of opposite sides being parallel as being a property that parallelograms have. Both pairs of opposite sides are parallel. One pair of opposite sides, both parallel and congruent, so both pairs of opposite sides parallel. That would be 2, 2, 2, 2. Little arrows there, and then these two would be parallel. Or one pair, both parallel and congruent, look like that. Now, if the other property that parallelograms have is all opposite sides are congruent, so that would be that one, that one, that one, and that one. All these opposite sides are congruent to each other. That's enough also to be a parallelogram. So what could we ask? What questions would you ask to determine whether it's a parallelogram? Mainly, are the opposite sides congruent? I mean, well, are all the opposite sides congruent? That's one thing you could ask. If all the opposite sides are congruent, it would have to be a parallelogram. Or are all the opposite sides parallel? So those are like the two basic questions we could ask. Okay, let's move on. Part B. What questions would you ask to determine whether figure 1 is a rectangle or whether figure 2 is a square? Okay, now figure 1 is a rectangle. It looks like a rectangle. And a property of a rectangle, okay, it's a parallelogram first off. Opposite sides are parallel. Opposite sides are congruent. But also, a rectangle has a right angle. And with same side interior angles, if this is a 90, since both of these have to be 180, this one's got to be a 90. Going this way, since remember this is a parallelogram also, going the other direction, these two angles have to be 180. So if one's 90, the other has to be 90. And then going this way, same thing, using same side interior angles and them having to be 90 degrees or supplementary with each other. So that's what it takes to be a rectangle. Pairs of opposite sides congruent. And first of all, it needs to be a parallelogram. That's the first question. If it's a parallelogram, a rectangle is a right angle. And then are opposite sides congruent? If so, it's a rectangle. Now, what about the square? The square has all the sides congruent. It has opposite sides parallel, just like a parallelogram, because it is one. It has opposite sides congruent, just like a rectangle, because it is one. And it has a right angle, which means that all the angles have to be right, just like a rectangle. because a square is one. But in addition, a square has all sides congruent. So what makes a square different from a rectangle is just in the fact that all the sides are congruent rather than pairs of opposite sides congruent. So for a square, is it a rectangle? So first, is it a parallelogram? Is it a rectangle? Which means, does it have all this other stuff over here? And then, are all sides congruent? So if it's a rectangle with all sides congruent, it's a square. Okay, now let's talk about figure 3. Figure 3 is a little bit different. Figure 3 also has all sides congruent. It also has opposite sides parallel because it's a parallelogram. But it doesn't have the right angle, and we call this one a rhombus, or H-O-M-B-U-S. So we have a square. A square is a rectangle. That has opposite sides congruent. A rhombus is a parallelogram that has all sides congruent. A square is also a parallelogram that has all sides congruent. So a square really has everything that a rhombus needs to have, but in addition, a square has a right angle. So a square is a rhombus with a right angle. And also, a square is a rectangle that has all sides congruent. So a square is a really special kind of figure. It's a rectangle and it's a rhombus at the same time. If all three figures are parallelograms, what's the most descriptive name for figure 3? Okay, figure 3 we call a rhombus. And the plural might be rhombi. Rhombi are parallelograms. With all sides congruent. Just maybe think of a square box. You get like this square box, right? And let's say you take and it's a square. So you take the bottom out and you push the opposite edges, opposite corners, vertices in towards each other. You make all these diamond type shapes that have equal sides. And those are what we call rhombi, or one of them is called a rhombus. Let's move on. Okay, let's look at example 1, the triad here. Let's see what we got. Let's see. What is the length of WY? So, in a rhombus, the diagonals are perpendicular bisectors of each other. Excuse me. So in a rhombus, the diagonals are perpendicular bisectors of each other. So to tell us this is a rhombus, and because it's a rhombus, the diagonals make right angles in the center. So those are all right triangles. And also, this diagonal is bisected by the other diagonal. So they're all broken up into congruent pieces. And they want to know what WY is. So they're giving us that this is a 3. Is this a 3? Yeah, this is a 3. So because of the bisector, that is also a 3. And they want to know what WY is. Now, WY is actually composed of this w to the middle and the middle to the y. So it's actually 2 of whatever this length is. So if we kind of draw the right triangle that goes with this, this has a side of 5, and it has one leg of 3, and this other leg is the one we don't know, and we have a right triangle. So the hypotenuse is C. We can let A be 3 and B be x, and we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. So we plug in what we have. C is 5, so 5 squared goes there. 3 could be either one of these. We'll put the 3 here, so we got 3 squared there. And this one we'll let be x. So 3 squared plus x squared is equal to 5 squared, which gives us 9 plus x squared is equal to 25. Take 9 away from both sides. X squared is equal to 16. And the square root of 16 is 4. So we're like taking the square root of both sides. So x is 4. Now if x is 4, this total wy length is 2 times 4 equals 8. Okay, here for part now, for part B, in a rhombus, okay, we were talking about the diagonals for part A, but in a rhombus, because it's a parallelogram, these opposite angles are congruent to each other, and also the diagonals bisect those opposite vertex angles. So this 70-degree angle is going to be a 70-degree angle over here because those angles are equal to each other. This angle up here is going to be bisected, and this by the PR diagonal, and this angle at R is also going to be bisected, and in addition, P and R are going to be congruent to each other. So let's see what we got. So we have a 70 and a 70. Now this is a quadrilateral, so 360 degrees is what the inside angles need to be. Two 70s make 140. So we're left with 220 degrees to make these two equal angles at P and R. So we divide by 2. Each one of those is going to be 110 degrees. So angle SPQ, measure of angle SPQ equals the measure of angle QRS equals 110 degrees. Now let's see what they're asking us. They're wanting to know what RPS is. RPS is half of this angle, of this 110 degree angle. And since this diagonal bisects this 110 degree angle, each half of this is going to be 55 degrees. So the measure of angle RPS is 55 degrees. Okay, let's look at example 2. I want to find the lengths in the measure. Okay, to tell us that each one of these is a rhombus, so we want to know the angle of MNO. So let's look. Now, this diagonal bisects this angle here. So if this is 62, this has to be 62. And each one of these has to be 62. So we've got 124 plus another 124 makes 248. Altogether, since this has got 4 sides, we need to have 360 total degrees. Those other two angles are going to be congruent, so we're going to subtract, find the difference, and divide by 2. It's going to give us a 12, so we get 112. Divided by 2, we get 66 degrees. So each one of these angles is 66 degrees. Now this diagonal here bisects the 66 degree angle, so each one of those is going to be 33 degrees. So let's see what they want. They want MNO. M to N to O. MNO is 66 degrees. Okay. Let's look at B. We want to know what what the distance from Q to T is. So they want us to find this distance right here. See how we can do that. Let's see. So now, again, we have a rhombus. So all the sides in the rhombus are congruent. So this 3y minus 1 side has to be equal to the 2y plus 3 side. And we need to find the y that makes that so. So let's see, get our y's on the left and our numbers on the right. So I'm going to add 1 to both sides. 3y's is equal to 2y plus 4. I'm going to take 2 y's away from both sides. So y is equal to 4. Okay. Now, out here, they're telling us that this total distance between Q and S is 5 times y minus 4. Now, if y is 4, we have 5 times 4, which is 20. Take away 4, which gives us 16 for this distance here. And it wants to know what QT distance is. QT, this PR diagonal bisects the QS diagonal, which is 16 long. So it must be half of 16, which is 8. That's the answer for that one. Let's look at example 3. Carpenter needs to check the gate as a apprentice built to be sure it's rectangular. The diagonals measure 52 by 53. Is the gate rectangular? So now in a rectangle, we have the right angles, but one important property of a rectangle is that the diagonals of a rectangle are congruent to each other, and they also bisect each other. And if one of these diagonals is 52 and the other one is 53, we have almost a rectangle, but it isn't quite a rectangle because diagonals in a rectangle have to be congruent. So no, it's not a rectangle because diagonals are not congruent. That's the reason that it's not a rectangle. Let's look at example 4. Find diagonal lengths of a rectangle. So we have a rectangle with an area of 1,600 square meters. So let's just kind of sketch a rectangle. Now this whole thing has got 1,600 square meters in it. The area, it's 4 times as long as it is wide. So if I let x be how wide it is, it's 4x long. And this area is 1,600. So length times width gives me 1,600. So x times 4x came out to be 1,600. This gives me 4x squared equals 1,600. Divide both sides by 4. X squared is 400. Take the square root of both sides. X equals 20. Now if x is 20, that's 20. This is 80. And we got the right angle there. And it wants to know what the sum of the diagonals are. Now here's one diagonal. And this other diagonal is congruent to it. So if we can find one length, we just need to double it. And if we notice what we have here is we have a right triangle because it's a rectangle with a right angle. One leg is 20, the other leg is 80. The length of the diagonal is actually the hypotenuse. So this is a Pythagorean theorem problem. A squared plus b squared is c squared. We can let a be the 20, b be the 80, and c be the length of the diagonal that we're trying to find. So a squared, 20 squared, plus b squared, which is 80 squared, is equal to c squared. 20 squared is 400. 80 squared is 6,400. That gives us 6,800. And we want to find the square root of 6,800 by taking the square root of both sides. So the square root comes out to be 82.46, so we'll call it 82.5. So that's the length of one diagonal, and it wants to know what's the sum of the diagonals. So each diagonal is 82.5. 2 times 82.5 is 165. And this is talking about meters, so 165 meters would be the answer for example 4. Let's look at example 5. Diagonals and angle measures in a square. Okay, so we have a square. Now, properties of a square, remember, it's a parallelogram. All sides are congruent, which makes it a rhombus. But in addition, it has all right angles. So it's a parallelogram, opposite sides are parallel. It's a rhombus, all sides are congruent, and it's a parallelogram. And in addition, it's a rectangle because it has opposite sides congruent and it has a right angle. So square ABCD has ABCD, has diagonals AC, change colors, and BD. So there's the diagonals. What is the measure of angle ABD? ABD wants to know the measure of this angle right here. Now, in a rhombus, the diagonals bisect the opposite angles. A square is a rhombus because a square is a parallelogram with all congruent sides. So this 90-degree angle is bisected by diagonal BD, and half of 90 is 45 degrees. So the measure of angle ABD equals 45. Let's move on. Okay, let's look at the number 1. What properties differentiate them from other parallelograms? Okay, regular parallelograms just have opposite sides parallel and opposite sides congruent. Rectangles have opposite sides congruent and in addition have a right angle. A square has opposite sides congruent. It actually has all sides congruent and a right angle. And a rhombus has all sides congruent. So all congruent sides in a rhombus. Squares and rectangles have right angles and opposite sides congruent. Well, all sides congruent in a square. And so this is a rhombus in a square. Has all congruent sides. A square and a rectangle has right angles. Other parallelograms just have opposite sides parallel and opposite sides congruent. They don't have the right angle, and they don't have all sides congruent. They just have pairs of sides congruent. Let's look at number 2. Okay, this is a rectangle. Rome wants to know the four interior wants to show that they're congruent. What's her error? So let's talk about this first off. If it's a rectangle, we know that those opposite sides are going to be congruent to each other. We know the diagonals are going to bisect. So it leaves those two pieces equal. And these two pieces equal. And then we know that we have vertical angles in the center. So by side angle side, these two angles are going to be congruent. And then by side angle side going this way, these two triangles are going to be congruent. Okay, so let's see what she did. Diagonals of rectangle are congruent and bisect each other. So RP is congruent to TP. Okay, so that's true. Because the diagonals are perpendicular bisectors. Now, there's the mistake. The diagonals are not perpendicular bisectors in a rectangle. In a rhombus, which would be a square, the diagonals would be perpendicular bisectors and make right angles. But in a rectangle, the properties of the parallelogram just come in, and the diagonals. Well, in a rectangle, the diagonals are going to be congruent to each other, and they're going to bisect each other. But they're not going to cross at a right angle because that only happens in a rhombus. So that was her mistake. Circuit number 3. Is any quadrilateral with 4 congruent sides a rhombus? No. A rhombus has to be a parallelogram with 4 congruent sides. So that kind of gets away from maybe an idea of something like this being a rhombus if all these sides happen to be congruent to each other. That's a little bit out of scale there. But it needs to be a parallelogram with all congruent sides. And that's what makes a rhombus. And if it is a rhombus, those diagonals are going to make right angles and be bisectors. Okay, let's look at the do you know hows. Find each length and angle measure. Okay, so let's just kind of fill this in and see how this goes. So this is going to be a 62. This is going to be a 62. This is going to be a 62. Now that gives 124. We have 2 of those, one at the top and the bottom. That's 248. Altogether, they have to be 360. It makes 112 difference. These 2 angles have to make 112. Half of it is going to be 56. And so this total angle is going to be 56, but half of 56 is 28. So these are all going to be 28s. You're going to be responsible for knowing how to do this. If this is a 5, this is a 5. Let me change colors up. This is a 5. This is a 5. And that's really all we can do for this. We can't do anything with these sides or anything like that. We don't know what these are. So let's see what we got. So it wants to know the length of DF. DF is going to be twice 5. That's going to be 10. A measure of DFG. DFG, that's 28 degrees. And EG. Now, EG, I don't see that we can find that without, well, okay, here they're telling us this is a 5.6. I didn't see that. Or I overlooked it. So these are all 5.6s. So they want us to know what EG is. EG is actually double whatever this distance here is. And so we can use this right triangle where this is a 5 and this is a 5.6. And we need to find out what this distance right here is, and then double that distance is going to be EG. So this is really like 1/2 of EG. So let's see what we got. 5.6 squared. So this is the version I'm doing. C squared minus B squared equals A squared to finish up the Pythagorean theorem. So 5.6 squared minus 5 squared equals A squared. Okay, 5, so let me see what that is on the calculator. Okay, that comes out to be 6.36. The difference of 5.6 squared minus 5 squared is 6.36. We want the square root of that. That's going to give us our A. And the square root of that is 2.52, so we'll call it 2.5. It's approximately equal to A. And this distance they're looking for EG is double the 2.5, so it's about equal to 5. This is rounded to the nearest tenth, so 2.5, 2.5, about 5.0. Number 7, find the length, each length for the rectangle, rounded to the nearest tenth. Okay, rectangle's got right angles. This is a 5. It means that's going to be a 5. If this is a 4, that's going to be a 4. So they want MP. So they want to know what the length of this diagonal here. Before we can find the length of this diagonal, well, okay, the diagonals in a rectangle are congruent. If NQ is 10, remember diagonals bisect, so that's how we know that's a 5. If NQ is 10, MP also has to be 10. And they want to know what MQ is. MQ is this length here. Well, for that one, we're most likely going to have to use the Pythagorean theorem, because we're talking about this triangle right here. And we want to find this distance here. So we've got a 10 and a 4. So we've got a hypotenuse of 10. One of the legs is a 4. And this other one, this NP side, is the side that we need to find. So we do 10 squared minus 4 squared, which is 100 take away 16, which is 84. And x is going to be the square root of 84. And the square root of 84 is about 9.2. So we found out that x was 9.2. And in terms of this triangle, we got our 10 and our 4. This is 9.2. So the length of MQ is the same as this one we just found, 9.2. Okay, let's look at number 9. Find length and angle measures for the square. Okay, now here we have a square. All sides are congruent. The diagonals bisect each other and are congruent. So those are all 7s. And let's see, XZ. So XZ is going to be twice the 7, which is 14. The measure of XWP, this angle here is going to be 45, because the diagonals in a rhombus, which is what the square is, except it also has a right angle, the diagonals in a rhombus bisect each other and also make right angles. So they're perpendicular bisectors. So this has got to be a 45. And YPZ, Y to P to Z, is going to be 90, because the diagonals in a rhombus are perpendicular bisectors. That leaves that being a 90-degree angle. So number 12. What's the value of x? Okay, we've got a couple of isosceles triangles here. Let's see. This is a base angle of this isosceles triangle. This is a vertex angle of this triangle. So using sort of like a isosceles triangle as a organizer here, they're telling us that this vertex angle is 8x minus 6. And now, since these two triangles are congruent by side, 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 this is also going to be the same as the vertex angle. And this 4x plus 5 is the same as this angle here, and these are the base angles. So the base angle is 4x plus 5. And so the other angle is also 4x plus 5. Altogether, these angles need to add up to 180 degrees. So adding the x's up, we have 4, 8, 16 x's. Plus 5 is 10. Plus a negative 6 leaves us with a 4. And altogether, they have to equal 180 degrees. So take a 4 away from both sides. 16 x's is 176. X is going to be 11. So if x was 11, this is 88, take away 6, which is 82. This is 44 and 5, which is 49. This one's got to be 49. So that's an 82. This is a 49. This is a 49. So these all add up to 180. And if this is a 49, this needs to be an 82, and this needs to be an 82. Is that right? No, it's not right. This is an 82. This is a 49. This is a 49. So 82 matches with 82, and then all the 49s also match up with each other.